The idea that a common sports supplement like creatine could play a role in managing mood disorders such as depression and anxiety may seem surprising at first. Yet, a growing body of preliminary research suggests that this naturally occurring compound, best known for enhancing athletic performance, may also influence brain chemistry in ways that support emotional stability. Specifically, creatine appears to enhance mitochondrial energy production in neurons and may support neurotransmitter systems involved in mood regulation, including serotonin. This has led researchers to explore its potential as an adjunctive therapy in mood disorders, particularly for individuals who do not fully respond to standard antidepressants or who experience treatment-resistant symptoms. At its core, creatine plays a vital role in cellular energy metabolism. In both muscle and brain tissue, it helps recycle adenosine diphosphate, ADP, back into adenosine triphosphate, ADP, the body's fundamental unit of energy. The brain is an energy-intensive organ, and when ADP availability is impaired, neurons may struggle to maintain optimal function. This includes the synthesis and signaling of mood-related neurotransmitters like serotonin, dopamine, and norepinephrine. In depression, there is often evidence of reduced brain energy metabolism and mitochondrial dysfunction, especially in areas such as the prefrontal cortex and hippocampus. By improving cellular energy availability, creatine may indirectly restore proper signaling in these critical regions. Preliminary human studies, though limited in scale, have shown promising results. In some clinical trials, creatine supplementation has been associated with reductions in depressive symptoms, particularly when used alongside selective serotonin reuptake inhibitors, SSRIs. One study involving women with major depressive disorder found that those taking 5 grams of creatine daily in addition to their antidepressant medication experienced greater improvements in mood compared to those on medication alone. Improvements were often seen within a few weeks, suggesting that creatine may help accelerate or enhance the effects of traditional treatments. While the mechanisms are not fully understood, creatine's support for energy metabolism, synaptic plasticity, and serotonergic transmission likely play a role. There is also early evidence that creatine may benefit people with bipolar depression, a condition notoriously difficult to treat. In some small trials, creatine has been shown to improve depressive symptoms without triggering mania, though more research is needed to confirm its safety and efficacy in this population. Likewise, studies exploring creatine's role in generalized anxiety disorder are still in their infancy, but anecdotal reports and animal models suggest potential calming effects, possibly through modulation of stress hormones like cortisol. The antidepressant potential of creatine may be even more relevant in populations already prone to low creatine levels, such as women, vegetarians, vegans, and individuals with chronic stress or poor nutrition. These groups may start with a relative creatine deficiency, making them more responsive to supplementation. Given that women are disproportionately affected by mood disorders and also tend to have lower baseline muscle creatine stores due to hormonal and dietary factors, this could represent a significant and underexplored therapeutic window. That said, creatine is not a replacement for conventional psychiatric treatment. Depression and anxiety are complex, multifactorial conditions that require a comprehensive and individualized approach. Psychotherapy, medication, lifestyle modification, sleep hygiene, and social support all play vital roles. Creatine, if used, should be seen as an adjunct, something that may enhance the overall therapeutic response, not substitute for it. Moreover, while creatine is generally safe, individuals with pre-existing kidney conditions or those on multiple medications should consult a physician before starting supplementation. There are also limitations to the existing research. Most trials to date have been small, short-term, and focused on specific subgroups, e.g., women, people already on antidepressants. Long-term safety and effectiveness are still not fully understood, especially when used in conjunction with other psychiatric medications. It's also unclear whether certain people, such as those with elevated baseline creatine levels or metabolic disorders, might see fewer benefits or even adverse effects. More robust, randomized controlled trials are needed to determine optimal dosages, duration, and patient profiles. Despite these uncertainties, the potential of creatine as a mood-supportive compound is both plausible and compelling. It offers a novel approach to a persistent clinical challenge: how to improve energy metabolism in the brain as a way of alleviating emotional distress. Unlike traditional antidepressants, which target neurotransmitter levels directly, creatine supports the underlying bioenergetic machinery that powers neurotransmission. This makes it a unique candidate for treatment augmentation, especially in people with sluggish therapeutic responses or mitochondrial vulnerabilities. In summary, while creatine is still far from being a first-line treatment for depression or anxiety, early findings suggest it may offer meaningful support when used thoughtfully and under medical guidance. By enhancing brain energy production, supporting serotonin signaling, and potentially reducing symptoms more quickly when paired with antidepressants, creatine could become part of a broader, more integrative strategy for improving mental health. It's another reminder that brain and body health are deeply intertwined, and that sometimes tools developed for muscle performance may have unexpected benefits for the mind.